Hi, we're now speaking to Dr. Milholland on his recent paper on evidence of there being a limit to human lifespan that was recently published in Nature. So, Dr. Milholland, could you please give us a summary of your paper?
Hi, so my lab is interested in aging, and we primarily study the basic biology of aging, but we also wanted to take a look at demographic data to see how effective we are at extending human life. And so we first looked at the life expectancy, which is the average amount of time that a person might live. And we found that was increasing and appears to still be increasing to this day. But then we wanted to shift our focus to the lifespan. And so first we looked at the number of people surviving to different ages. So the number of people surviving to 70 is going up, surviving to 80 is going up, surviving to 100 is going up. But then after 100, then the rate of increase starts to get lower and lower. So more people are surviving to 105, but that's going up more slowly than the amount surviving to 100. And then the amount of people surviving to 110 is going up even more slowly than that. We then looked at the life expectancy of people who do reach 110 years old. You know, when somebody is 110, how much longer do they have to live, and how has that changed over time? And we found that they'll probably live to be at 111, and that hasn't changed since the 60s. We then looked at the ages of the absolute oldest people in the world to see if the world record holders for oldest person, when they died, was going up. And we found that although that had been going up for quite a while, in the late 90s, that stopped going up, and it's been pretty much constant since then. So then we tried looking at what is the average age of the oldest person when they die. And we found that is about 115 years old. So we think that for the foreseeable future, the oldest person in the world will be about 115. Now, some people might live a little bit longer than that, but then the odds get worse and worse. And we figured, we did a calculation, and we found that the chance of somebody reaching the age of 125 is about 1 in 10,000, and that's anybody in the whole world. So somebody reaching that age should happen only about once every 10,000 years. So from that, we concluded that there's a limit to human lifespan. It's not a hard limit, but it's 115, and after that, it is a very difficult thing to live longer, and really, if you want the absolute limit with really no hope of increasing above, it's 125.
So do you think that basically because of your sample has been taken from people that are alive, well, recently or to 1995, do you think the effects of the 20th century in the fact that we didn't have modern medicine that we have now, we had 2 world wars, do you think those effects, so basically the events that happen in these people's lifetime will have an effect? So do you basically think that potentially if we had like maybe a century of really good healthcare for everybody, could you then have people living to longer than 115?
These people are already living in countries with very good healthcare. It's true they did live through some, difficult times like world wars and all that, but they survived. In the general population, okay, a lot of people died, and in terms of not having so many wars and having better healthcare, having more vaccinations, better access to antibiotics, that has helped the population as a whole live longer, and that's why we've seen the life expectancy go up from like 50 years to now it's in the late 70s in most developed countries. But then looking at the absolute maximum of the lifespan, those people aren't dying from war, and they're not dying from like easily preventable, communicable diseases. And so, although those things have helped the population as a whole, they don't help reduce the late life mortality. And that basically tells us that we've gotten very good at treating people from dying early in life, which is good. But then the things that people die of very late in life, medicine has really not addressed that.
And so do you think this, so basically when you get to that age, you will die of old age. Do you think there is like a biological reason for this, or is this a benefit thing? Or do you think you could actually, start replacing organs that start to fail?
So, we can replace organs. You can get a heart transplant or a lung transplant. What we think happens is that as people age, they begin to accumulate damage throughout their body. And primarily, our lab focuses on somatic mutations, which are mutations present in single cells. And so as people accumulate these mutations and they accumulate the damage overall, it actually affects the whole body, everywhere throughout the body. Everything starts to fall apart. And now medicine, we can replace one organ at a time, maybe two if you try very hard, or you can give somebody a medicine that will try to compensate for that one of their organs isn't functioning very well. And so that has kind of extended lifespan a bit, even for late life mortality. But ultimately, at extreme old ages, everything is falling apart. Medicine can't compete, and medicine isn't really doing anything about the underlying damage. It's treating, to some extent, the symptoms, or even sort of the superficial causes, but the deep cause, we think, is not being addressed by medicine. And that's why there's now this limit to lifespan that even the latest technology cannot surpass.
Oh, that's really interesting. One last question. What do you think the effect of things like gene therapy will be?
So gene therapy, we don't have it developed yet for use in humans. It's very good at replacing maybe one gene at a time. And so somebody who gets an inherited disorder like cystic fibrosis, we could come in with gene therapy, fix that defective gene, and instead of them dying at 30, they could live a normal life, and that would be great. In terms of what makes people live longer or shorter, a lot of it is environmental, and we've done about as much as we can in that regard. There is some genetic component, but then you have to think there's not like one single gene to make people live very long. There must be many different genes that has a very small effect. So if we thought, oh, what's the absolute best complement of genes that we could get? And could we give that to everybody through gene therapy? Well, we need to replace like 1,000 genes or something. And when we don't even have gene therapy for one gene, doing 1,000 rounds of gene therapy is just not something that we can even think about right now. And even then it would only be a limited effect because there's environmental things, there's a bit of luck involved. And then the somatic mutations I mentioned, those are present in every single cell, and they're different in every single cell. And that is trillions of cells. And how are you going to fix all of those cells all at once? So unfortunately, I don't think gene therapy by itself, as we know it, is going to cause a radical extension of human lifespan for most people.
Yeah, that's great. Thank you for, well, not great, but you know what I mean. Thank you so much for speaking to us. I'll put the link to the paper below this. And thank you again. It was very interesting.
Well, thank you for having me. Bye.